Study optics here. First we will give interference, then Fraunhofer diffraction, Fresnel diffraction, geometrical optics, polarizations, coherence, and the line radiation. Interference. So first Newton's ring. So nth dark ring will be Rn square equal to nr lambda 0. Rn is radius of nth ring, r is the lens radius of curvature, and lambda 0 is the wavelength of the external medium. N bright will be n plus half of r lambda 0. Now dielectric layers. So for a single layer, let's say eta 1, eta 2, eta 3 are the refractive index, and incident intensity is 1. Reflected will be r, and transmitted will be 1 minus r, and the width is a. Similarly, eta a, eta b for multi-layer, and Rn is the reflectant and the transmitted is 1 minus Rn. So for quarter wave condition, eta the refractive index times some distance equal to lambda by t. This distance is a by m. A is the thickness of the film and m is the thickness integer. So single layer reflectance, this r, when m is even, will divide evenly the total width, then eta 1 minus eta 3 by eta 1 plus eta 3. For m odd, eta 1 eta 3 minus eta 2 square, eta 1 eta 3 plus eta 2 square whole square. Dependence of r on layer thickness. So r is 0 when eta 2 equal to eta 1 eta 3 to the power half. Otherwise it will have maximum if this condition satisfied, or minimum if this condition satisfied. So this value is greater than 0, then maximum, less than 0 is then minimum. Multilayer reflectance, eta Rn equal to eta 1 minus eta 2 Na by Nb divided by eta 1 plus eta 3 eta A by eta B 2n to the power 2. Fabry-Perot interferometer. Let's say incident wave coming here, again transmitted, reflected back, again transmitted, finally again this reflected light, again reflected, internal reflection, and then again out. Some portion will come again like that we will get parallel output lines that has been transmitted. So the combination of this light transmitted from here, it will also create an interference on the screen. So it is called Fabry-Perot etalon. So increment phase difference phi equal to 2 k0 h eta dash cos theta. For maxima it is 2 pi n. Incremental phase difference, coefficient of finenesses, transmitted intensity, fringe intensity profile, chromatic resolution power, resolving power, free spectrum range, that we can calculate. Now grating, Young's double slit formula. Is is the intensity equal to I0 cos square dk sin theta by 2. D is the distance between two slits, and k is 2 pi by lambda, and so this is Young double slit. For equal slit, we have this d will be small d times n. So small d times n. So total intensity will be I0 sine of nd k sin theta by 2 by n times sin k ds by 2. For infinite grid, we have intensity Is Normal incidence sin d sin theta equal to n lambda. For chromatic resolving, lambda by d lambda equal to n times n. N is the number of slits and small n is the order of diffraction. Grating dispersion formula, delta theta by del lambda equal to n by d of cos theta. Bragg law, 2a sin theta equal to n lambda. A is the distance between two planes. Aperture diffraction. So for circular aperture, intensity will be I0 2 times J1 of kd sin theta by 2 divided by kd sin theta by 2 whole square. So J1 is the first order Bessel function. First minima will be sin theta equal to or d sin theta equal to 1.22 lambda. First maxima equal to 1.6 d sin theta equal to 1.64 lambda. This is for first maxima. For first minima 1.22 lambda. Fresnel's diffraction, Kirchhoff's diffraction formula. So source at infinity. So source at infinity, complex amplitude at P will be this formula. Here k theta is the obliquity factor equal to half of 1 plus cos of theta. Source at finite distance, then psi p will have this following formula. For source at infinity, we have this formula. Fresnel's zone, the effective aperture distance equal to 1 by z equal to 1 plus z1 plus 1 by z2. So source aperture distance and aperture observer distance. Half period zone, yn equal to n lambda z to the power 1 by 2. Axial 0, that is for circular aperture, zm equal to r square by 2m lambda. Cornu spiral, these are Fresnel's integrals cw and sw. This is 0 to w cos pi t square by 2 dt and sw is sin pi t square by 2 dt. Cornu spiral, c time s omega equal to c omega plus is omega and cs equal to plus minus half 1 plus I. Edge diffraction, psi p, and diffraction from a long slit. A diffraction from a rectangular aperture is this wave function. Here geometrical optics, we have lens and mirrors. Lens r is the center to right, u is the real object distance and v is the real image distance. Now Fermat principle, L equal to eta dl, this is constant. The light will follow the smallest path. So lens formula, 1 by focal length equal to 1 by u plus 1 by v. U and v are object distance and image distance. Newton's lens formula, x1 x2 equal to f square. x1 is v minus f and x2 is u minus f. So lens maker formula, 1 by u plus 1 by v equal to eta minus 1 by r1 minus 1 by r2. R1 and R2 are radius of curvature of the lens surface. Binor formula, 1 by u plus 1 by v equal to 1 by f, that equal to minus 2 by r. Dioptry number, d equal to 1 by focal length. Focal ratio, n equal to f by small d. D is the length or mirror diameter. Transverse linear magnification V by U minus V by U. Longitudinal linear magnification ml equal to minus mt square. If the incident angle is I theta on a prism and alpha is the angle of the vortex, then the transmitted angle will follow the following formula: sin theta t equal to eta square minus sin theta square to the power half sin alpha minus sin I cos alpha. Deviation delta equal to theta I plus theta t minus alpha. This is the deviation. Minimum deviation condition: sin theta I equal to sin theta t equal to eta times sin alpha by 2. Refractive index eta equal to sin dm plus alpha by 2 by sin alpha by 2. Here dm is the minimum deviation and alpha is the apex angle, this angle. Angular dispersion d equal to del d of delta by d of lambda, that equal to sin alpha 2 sin alpha by 2 by cos d plus alpha by 2 d eta by d lambda. For a optical fiber, we have two different layers. First layer with large refractive index NF and the shading with have lesser refractive index. So NF is larger than NC. So accepted angle theta m, that we have to that is the minimum angle we have to fall the light, so that it will have the total integral reflection. So sin theta m equal to 1 by eta 0. Eta 0 is the exterior refractive index. In case of air, it is 1. Eta f square minus eta c square to the power half. That is the accepted angle. Numerical aperture n equal to eta 0 of sin theta m. For polarization, for elliptical polarization, E is the electric field has to be E0x E0y times e to the power I delta times e to the power I kz minus omega t, and polarized angle alpha will follow the expression tan 2 alpha equal to 2 E0x E0y divided by E0x square minus E0y square cos of delta. For Mellor's law, I theta equal to I0 plus cos square theta. Jones vectors and matrices. Normalize electric field. So Ex equal to 1 0 at 45 degree 1 by root 2 1 1. Left hand circular, in case of right hand circular, 1 by root 2 1 my I, and for right hand 1 by root 2 1 minus I. Jones matrix Et equal to A Ei, Et equal to transmitted vector, A equal to incident vector. For linear polarized along x axis we will have 1 0 0 1. For y axis we have 0 1 1 0 0 0 1. Polarized at 45 degree 1 by 2 1 1 1 1 minus 45 degree half of 1 minus 1 minus 1 1. Right circular we have half of 1 I minus I 1. Left circular half of 1 minus 1 minus I 1. 4 by pi by 4 plates, e to the power I pi by 4 1 0 0 I pi by 4. First plate e to the power I pi by 4 I 1 0 0 minus 1. Now Stokes parameters. Electric field Ex equal to E0x e to the power I kz minus omega t. Ey equal to E0y e to the power I kz minus omega t plus delta. So delta is the relative phase difference. Axial ratio is tan of xi. Xi is this angle. So tan xi equal to plus minus r. R is the axial ratio, equal to b by a, plus minus b by a. Stokes parameter, I equal to ex square plus ey square, q equal to ex square minus ey square average. So similarly we can calculate uv. So based on iq uv, we can calculate the degrees of polarization. P as q square plus u square plus v square to the power half by I equal to always less than equal to 1. So for left circular, right circular, we can get this q, u, v, these values for different polarization. Coherence, mutual coherence function gamma ij can be expressed like this, and other parameters we don't need here. Complex degrees of coherence, combined intensity, fringe visibility, complex degrees of temporal coherence, coherence time and length, complex degrees of spatial coherence, intensity of correlations, speckle intensity distribution, speckle size. Line radiation, the spectral line broadening, natural broadening I omega, that is normalized intensity, will be 2 pi tau to the power minus 1, 2 tau to the power minus 2 plus omega minus omega 0. Tau is the lifetime of the excited state. And natural width delta w equal to 1 by 2 tau. Collisional broadening I omega, that also can be pi t to the power tc of minus 1, tc of minus 2 plus omega minus omega 0 square whole square. Similarly, we can calculate collisional and pressure half width, Doppler broadening, Doppler half width. Einstein coefficients. So R12 equal to B12 I nu Ni. R12 is the transition rate from 1 to 2, and B12 is the Einstein B coefficients. IV is the spatial intensity of the radiation field, and Ni is the number density of the atom in the quantum level of 1. Spontaneous emission R21 equal to RA21 N2. Stimulated emission R21 dash equal to B21 I nu N1 N2. Coefficient ratio A21 B21 equal to 2 pi nu square by c square G1 by G2, and G1 by G2 is B21 by B12. So now lasers. So we have two mirrors here, and laser light will follow the one of the mirror. So cavity stability condition, so it will be within 0 to 1, and the value of that will be 1 minus L by R1 and 1 minus L by R2. That will be greater than 0 and less than 1. Longitudinal cavity modes nu n equal to c by 2l times n. N is the integer. Cavity Q can be expressed like this. Cavity line with delta nu c, full with half maxima, is nu n by Q. Shallow Towner line width and threshold lacing conditions. This R1 R2 e to the power 2 times alpha minus beta times L is greater than always 1.